Imagine a way to fight cancer by essentially starving the disease at its core. This isn't science fiction, it's a growing field of study focused on cancer metabolism. For decades, the conventional approach to cancer treatment has centered around surgery, chemotherapy, and radiation. While these methods have their place, they often come with debilitating side effects and don't always address the root cause of the disease. A growing body of evidence suggests that cancer is not just a genetic disease, but also a metabolic one, intricately linked to how cells produce energy. This understanding opens up exciting new possibilities for treatment, including the use of ketogenic diets. The ketogenic diet, a high-fat, low-carbohydrate way of eating, has gained significant attention for its potential to impact cancer growth. This approach focuses on altering the way cancer cells fuel themselves, essentially cutting off their energy supply. By understanding the metabolic pathways of cancer, we can explore alternative strategies that complement conventional treatments and offer new hope to patients. This video delves into the science behind cancer metabolism, the potential of the ketogenic diet, and why this approach deserves further investigation and wider acceptance. Almost a century ago, Otto Warburg, a Nobel laureate in physiology or medicine, made a groundbreaking discovery. He observed that cancer cells, unlike healthy cells, primarily rely on a less efficient process called fermentation to produce energy even in the presence of oxygen. This phenomenon, now known as the Warburg Effect, became a cornerstone in understanding cancer metabolism. Normal cells typically generate energy through a process called oxidative phosphorylation, which takes place in the mitochondria, often referred to as the powerhouses of the cell. This process is highly efficient, yielding a significant amount of energy from glucose. However, cancer cells, for reasons not entirely understood, tend to favor glycolysis, a less efficient pathway that occurs in the cytoplasm and produces lactic acid as a byproduct. This discovery has profound implications for cancer treatment. By understanding that cancer cells are addicted to glucose, we can start to see how dietary interventions, particularly those that limit glucose availability, might hold therapeutic potential. This is where the ketogenic diet comes into play. The Warburg Effect suggests that interfering with glucose metabolism could potentially inhibit cancer cell growth. This understanding has paved the way for dietary strategies like the ketogenic diet, aiming to starve cancer cells by limiting their primary fuel source. This metabolic approach offers a novel perspective on cancer treatment, focusing on altering the energy landscape of the tumor microenvironment to make it less hospitable for cancer cell survival and proliferation. The ketogenic diet, characterized by its high fat, moderate protein, and very low carbohydrate content, forces the body to shift its primary energy source from glucose to ketones. Ketones are produced by the liver from fat when glucose is scarce and serve as an alternative fuel source for the brain and other organs. Numerous preclinical studies conducted in laboratory settings and using animal models have shown that the ketogenic diet can slow down tumor growth and in some instances even lead to tumor regression. These studies provide compelling evidence to suggest that the ketogenic diet can impact cancer progression by altering the metabolic environment in which cancer cells thrive. However, it's important to acknowledge that while these preclinical studies offer promising insights, more research, particularly large-scale clinical trials involving human participants, is needed to confirm these findings and establish the efficacy of the ketogenic diet as a viable cancer treatment option. Despite the growing body of preclinical evidence, the ketogenic diet's role in cancer treatment remains a topic of debate within the medical community. This is partly due to the lack of large-scale clinical trials, which are essential for establishing definitive conclusions about its effectiveness in humans. Additionally, the complexity of cancer, with its various types and subtypes, makes it challenging to generalize findings across all forms of the disease. While scientific research is crucial, the experiences of individuals who have incorporated the ketogenic diet into their cancer care regimen provide compelling anecdotal evidence. There are countless stories of patients who have reported significant improvements in their condition after adopting a ketogenic lifestyle. One such story is that of Emily, a young woman diagnosed with brain cancer. Given a grim prognosis, Emily decided to explore alternative approaches alongside conventional treatments. She adopted a strict ketogenic diet and diligently tracked her ketone levels. To the astonishment of her doctors, her tumor size significantly reduced, and she experienced a remarkable improvement in her overall well-being. Another inspiring account is that of John, a middle-aged man battling colon cancer. Frustrated with the debilitating side effects of chemotherapy, John decided to complement his treatment with a ketogenic diet. He noticed a significant increase in his energy levels and a marked reduction in inflammation. While John's journey is ongoing, his story highlights the potential of the ketogenic diet to improve quality of life during cancer treatment. These stories, while individual experiences and not necessarily representative of all cases, offer a beacon of hope and underscore the importance of exploring all available options, including dietary interventions, in the fight against cancer. They highlight the potential of the ketogenic diet to not only impact tumor growth, but also to improve overall well-being and quality of life during treatment. If you enjoyed this video, don't forget